Alright, ladies and gents, today we are going to talk about the structure of the atom and isotopes. So, we're going to look at the structure. And what we'll see here is just basically going to give you a basic schematic of what a generic atom would look like. There's three essential parts that we'll go over, subatomic particles. So basically what you'll have is a large shell on the outside, which we'll denote with these dashed lines. And these are what you would call your valence electrons. So these guys will always be on the outside, and I'm going to denote electrons with that E and the little minus superscript, just to make things shorter. So what happens is you have different shells of electrons, which I'll represent with some concentric circles going towards the inside. And basically, depending on how many electrons your element holds, will tell you how many shells you'll have. Whatever the outside shell is will always be the valence shell. So that's what actually shares electrons, and that's where bonding actually occurs in atoms. So, if you're ever asked, well, where does bonding occur? You can say the valence shell of electrons. This would be because valence electrons are easier to share because they're farther away from the center, which I'm representing with a dot, which is called the nucleus. Basically, the nucleus likes to pull on all these guys, so the little force arrows in, going all around. And basically, the force of the pull is stronger near the middle as compared to the outside. So these guys are the easiest to share. So now, if we go into the middle of the circle, and this is a very big dot in comparison to this, this guy right here, got a little squiggly line going, is called the nucleus. So nucleus is composed of protons and neutrons. So protons, neutrons, and electrons are the three subatomic particles which make up the actual atom. So relatively in size, this field right here, this whole circle, is roughly 10,000 times bigger than where all of the protons and neutrons are kept. So the electrons are moving in all kinds of places, while the neutrons and protons kind of stay to the middle. They like to stick together. So if you had a schematic of what that would look like, you would see a bunch of dots, and they would all be clustered together, and the protons and neutrons are just kind of hanging out with one another. So they're good buddies. So anyway, this is kind of a representative picture of what's going on in there. So just another thing while we're on the subject of neutrons, let's go over isotopes real quick. And again, just to sum up the structure of an atom, like I said, these dashed lines represent different shells of electron shells. So valence shells are the outside part, and then you have different levels of shells all the way in. So basically, the farther in you are, the stronger the pull is on the actual electrons, and that's why bonding occurs on the outside, because the electrons are easiest to share out on the edge. So let's move on to neutrons and protons and isotopes. So we'll get rid of this sheet and we'll bring another one in. So basically, isotopes, we'll cover this, give a general definition of what they are, and then go over an example using hydrogen. Isotopes are just different numbers of neutrons within the same element. So there's only a change in the number of neutrons. So I can't stress how important it is to say that it's just the neutrons, not protons, because if you change The protons, you actually change the entire element. So if you're ever asked to give an isotope, don't ever say, you know, oh, well, we increased the protons by 1 or 2, because that would actually change it to a completely different element. So let's do an example of isotopes. So get an example going real quick. And basically, we're going to start with hydrogen. So hydrogen has 1 proton and 1 neutron. So 1p and 1n. So 1 proton, 1 neutron. Deuterium is an isotope of hydrogen, and that actually has 1 proton and 2 neutrons. So just kind of seeing a trend here, you always have the same amount of protons, but you can change your amount of neutrons. And then a second isotope of hydrogen is called tritium. This one has 1 proton, and you guessed it, 3 neutrons. So, all pretty basic here. Basically, you keep the same amount of protons, and you can vary your neutrons. Depending on what element you have, if it's a higher number, so say chlorine, for example, you can actually have either 1 neutron up or 1 neutron below its ground state or most popular state. Take carbon, for example. Carbon-12 is your most popular isotope. That's the one you see occur most in nature, what have you. It's about 99% of the time there. So if we wanted to represent pictorially what this would look like, you would have hydrogen 3 times. So you draw an H, which is the atomic symbol for hydrogen. You always put protons in the top left, and then you can put neutrons on the bottom left. So if someone shows you this, well, you can look at them and say, this is hydrogen, this one's deuterium, and this one's tritium. And that's based on the number of neutrons which you see. Other than that, it's pretty simple. Like I said, if you have higher numbers, you can go above or below your ground state. Yeah, other than that, we are good.